Hello and welcome back to another Orange Coast College Mathematics video. In this video we are going to be solving equations that have rational exponents by using factoring. Now let's go ahead and just jump right into it. So first off, for number 1, we want to solve x to the 3/4 power minus 5 times x to the 1/4 power is equal to 0. Dealing with this on its own might be a little weird. However, I do notice that each of these x's has a fourth in their exponent. And so let's try factoring that out. If we factor out x to the 1/4, we're going to have x to the 1/4 power times x to the 3/4 minus 1/4 is going to give us 2/4 power. And then minus 5 times x to the 0 power is equal to 0. Now this is just going to become x to the 1/4 times x to the 1/2 minus 5 is equal to 0. Now our zero product property tells me that x to the 1/4 has to be equal to 0, which implies that x is going to be equal to 0, and that x to the 1/2 power minus 5 is also going to be equal to 0. Now this one implies that x to the 1/2 is going to be equal to 5. However, a 1/2 power is really a square root. So we can say the square root of x is equal to 5. If we square both sides, we're going to get that x is equal to 25. And so we have two values, x equals 0 and x equals 25. And that's our answer. So let's go ahead and move on down to number 2. So this one's a little tricky. We have x to the first power minus 4 times x to the 1/2 power, and then minus 12, a constant, is equal to 0. It's a little hard to see, but this is actually a quadratic. We can write x to the first power as x to the 1/2 power quantity squared. And so writing the rest in, we'll have minus 4 times x to the 1/2 minus 12 is equal to 0. Now, if you can see that this is a quadratic without having to do anything else, awesome. However, what I personally like to do is I like to give these things a new name. So I'm going to let x to the 1/2 be equal to a. And so substituting that in, we're going to have a squared minus 4 times a minus 12 is equal to 0. Now it's a little bit easier to see that this is a quadratic. We have a squared term, we have a first power term, and we have a constant. So we can go ahead and factor this. We have a minus 6, and then a plus 2 is going to be equal to 0. Now my zero product property is going to tell me that a minus 6 is going to be equal to 0, and then a plus 2 is also going to be equal to 0. This of course tells me that a is equal to 6, and that a is equal to negative 2. Now I'm not trying to solve for a, I want to solve for x, and so we can go ahead and substitute our x to the 1/2 back in. So this becomes x to the 1/2 is equal to 6, and x to the 1/2 power is equal to negative 2. Now again, the 1/2 power is really a square root. So we have the square root of x is equal to 6, and the square root of x is equal to negative 2. Now if we square both sides for the square root of x equals 6, we're going to see that x is equal to 36. And so that's one of our solutions. Now before we go ahead and start squaring this right side, we need to see if this actually makes sense. Can the square root of x be equal to a negative number? No, the square root function does not allow for negative numbers. And so we can actually say that this is not possible. So our only solution is actually just going to be x equals 36. So let's go ahead and try out number 3 now. Now for this one, I see that this term and this term both have an x minus 4 piece. So I'm going to go ahead and factor out an x minus 4 to the negative 1/2 power. So this is going to become x minus 4 to the negative 1/2 power times 3 times x minus 4. The 1/2 minus negative 1/2 is going to give us a 1 power. And then we'll have plus x times x minus 4 to the 0 power. But that's just 1. So we'll leave it like that. And this whole thing is equal to 0. Now I can go ahead and distribute this 3, and then we can combine like terms later. So we're going to have x minus 4 to the negative 1/2 power times 3x minus 12, and then plus x times 1, or just x. Now, combining like terms, we're going to have x minus 4 to the negative 1/2 power times 4x minus 12 is equal to 0. Now from here, we can use the zero product property, but one thing that I personally like to do is I will write this negative 1/2 exponent as a positive exponent by moving it to the denominator. And so this left side is going to become 4x minus 12 divided by x minus 4 to the positive 1/2, which again, just as a reminder, is a square root. This whole thing is equal to 0. Now we get to think to ourselves, I have a fraction is equal to 0. When is a fraction ever equal to 0? Well, a fraction is only ever equal to 0 when its numerator is equal to 0. For example, 0 divided by 5 is 0. 0 divided by 10 is still 0. 0 divided by 100 is also still 0. So a fraction is only equal to 0 when its numerator is equal to 0. And so we can really say that this is going to imply that 4x minus 12 has to be equal to 0. Adding 12 over and then dividing by 4 gives us that x is equal to 3. And so this is our only possible value that's going to make this equation true. Now, you may be tempted to just box this and call it your answer. However, we need to be careful. This left side has a denominator of x minus 4 to the 1/2 power. This 1/2 is a square root, and square roots can only have non-negative numbers. If I try plugging in 3, what's going to happen? I'm going to have 3 minus 4 in a square root. 3 minus 4 is negative 1. I'm not allowed to have negative numbers in a square root. And so, even though this does technically make the numerator equal to 0, I can't actually plug it in. It's not in my domain. And so, there's actually no possible solution. So let's go ahead and try out number 4. Now number 4 is similar. We have an x plus 3 in both of these terms. And so let's go ahead and factor out this x plus 3 to the negative 1/3. If we do, we're going to have x plus 3 to the negative 1/3 times x minus 6 times x plus 3. 2/3 minus negative 1/3 is going to give us 1. And then this whole thing is equal to 0. So from here, we can go ahead and just distribute this negative 6 to both of these pieces here. And so we're going to get x plus 3 to the negative 1/3 power, x minus 6x minus 18. And this whole thing's equal to 0. We can go ahead and combine like terms. So we're going to have x plus 3 to the negative 1/3 power, and then times x minus 6x is negative 5x minus 18 is equal to 0. Now from here we can use the zero product property, or we can continue on like we did last time, and so I'm going to do that. So this left side is going to become negative 5x minus 18 divided by x plus 3 to the positive 1/3 power, and then that's going to be equal to 0. Now again, the same logic, I have a fraction is equal to 0. This implies that my numerator has to be equal to 0. And so we can say negative 5x minus 18 has to be equal to 0. And so negative 5x is equal to 18, and hence x is equal to negative 18 over 5. Now we can go ahead and see if this is going to cause any problems, and realistically, we just want to see if this is going to cause a problem in our denominator. One thing that's slightly different, however, is that this is not a 1/2 exponent. It is a 1/3 exponent, which means that this is a cube root. A cube root can allow for negative numbers. So, as long as this thing doesn't make this turn into 0, we're good to go. Negative 18 divided by 5 plus 3 is not going to give us 0, and so this really is a solution. Okay, so let's move on down to our last problem. From here, I can see that there is an x to the 1/3, and I also have an x to the 7/3. Now, because they both kind of have this thirds property, let's go ahead and factor x to the 1/3 out. If I do, this is going to become x to the 1/3 power times x plus 2 quantity squared plus 2 times x squared. Now, inside our brackets, we can go ahead and expand. So we're going to have x to the 1/3 power times x squared plus 4x plus 4, and then we have this plus 2x squared. Combining like terms, we're going to have x to the 1/3 and then times 3x squared plus 4x and then plus 4 is equal to 0. Now, our zero product property tells us that x to the 1/3 has to be equal to 0, and so x is going to be equal to 0 is one of our solutions. It also says that 3x squared plus 4x plus 4 is going to be equal to 0 as well. Now, this doesn't look like it factors particularly easy, so let's just use the quadratic formula, which says that x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c, and then this whole thing is divided by 2 times a. And that is where a is the coefficient on x squared, b is the coefficient on x, and then c is our constant. So we're going to get that x is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 3 times 4, and then this whole thing divided by 2 times 3. Multiplying our constants together, we're going to have x is equal to negative 4 plus or minus the square root of 16 minus 48, all divided by 6. Now this is going to become x equals negative 4 plus or minus the square root of negative 32 divided by 6. Now from here, I can write the square root of negative 32 as the square root of 32 times I. And so we'll have x equals negative 4 plus or minus the square root of 32, I, all divided by 6. Now the square root of 32 can be written as the square root of 16 times the square root of 2. And so we get x is equal to negative 4 plus or minus the square root of 16 times the square root of 2, I, and then all divided by 6. Now the square root of 16 is just going to be 4, and so we're going to get that x is equal to negative 4 plus or minus 4 times the square root of 2, I, all over 6. Now let's go ahead and separate this at our plus and minus. So we'll have two answers. The positive one is going to be x equals negative 4 plus 4 times the square root of 2i all over 6, which then becomes x equals negative 2/3 plus 2 times the square root of 2 over 3 times I. The negative version becomes x equals negative 4 minus 4 times the square root of 2i all over 6, which then becomes x equals negative 2/3 minus 2 square root 2 over 3, and then times I. Combining this with our answer of x equals 0 from earlier, we have all three of our solutions. And so, we're done with our problem. Well, that's going to do it for this video, and I hope to see you in the next one.